Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. At a party, 7 people put their coats in the back room where the coats are mixed together. Each person then randomly selects one coat. Let the random variable x be the number of people who select their own coat. Find E of x. And here is the solution. Let us begin with this question. Given m elements, how many permutations of those m elements move all elements? So do not keep any elements fixed in their place. Such permutations are called derangements. Let us write Pm for the set of all permutations of m elements, and Dm for the number of derangements of the same elements. And let us write Ai for the number of permutations that leave the ith element fixed, for I equal to 1, 2, through m, and number of E, the number of elements of a finite set E. Then we have this, that the number of Pm is m factorial, that's what we know from what we learned about permutations, you should have. And the number of Ai, it's m minus 1 factorial, because if one element is fixed in place, then all the others are permutated in some way. Then there are only m minus 1 elements that are changing, moving around, and so we basically have all permutations of those m minus 1 elements for I equal 1, 2 through m. We're doing this for every single of these elements, this calculation separately. Okay. Of course, the number of permutations that leave the first element fixed is the same as the number of permutations that leave the 10th elements fixed. It doesn't really matter. That's why we always get m minus 1 factorial. And most importantly, dm is equal to pm, so derangements, that's all permutations except for those that leave at least one element in place. And those permutations that leave at least one element in place, well, that's a union of all AIs. Therefore, using the formula for the property of a union, but applied to the count of the number of elements in the set, the number of dm is the number of pm minus the sum from I equal 1 to m of the number of AI plus the sum over all I1 less than Y2, which lie between 1 and m, of the number of elements of AI1 intersection A1, 2, minus the next one will have the collections of 3 intersections. Next one will have a plus with 4 intersections, so on, and the last one will be negative 1 to the nth times the number of elements in A1 intersection A2 through AM. And that's m factorial times m choose 1 times m minus 1 factorial plus m choose 2, the 2 elements that we pick out of m, just like there was 1 before m choose 1, times m minus 2 factorial, minus, plus, and so on, up to negative 1 to the nth times m choose m times 0 factorial. So that's m factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial, and so on up to negative 1 to the nth times 1 over m factorial. And now we're going to use this formula for this special case that we're analyzing. So we know there are 7 factorial ways to arrange the codes, and those arrangements form the sample space. Probability that x is 0 is 7 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial plus 1 over 6 factorial minus 1 over 7 factorial, the whole thing divided by 7 factorial. And we can do it two ways. We can just cancel out the 7 factorial and try to calculate the sum, or we can just multiply the 7 factorial by what we see there. Note that 1 minus 1, the first two terms, actually cancel out. So we start with really 7 factorial times 1 over 2 factorial, which is 3 times 4 times 5 times 6 times 7. And we do that for the remaining terms, and this is what you see is what we get. And the whole thing is divided by 7 factorial. That ends up being 309 over 4 times 5 times 6 times 7. And that's equal to 103 over 280. If one person matches his or her code and the other ones do not match, there are 7 ways to pick that person, so that the probability of x is 1 is 7 times 6 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial and so on up to 1 over 6 factorial divided by 7 factorial. Well, this time I just did cancel out the 7 factorial basically, but still the calculation is just as tedious, and after the calculation we eventually get 53 over 144. Probability that x is 2 is 7, choose 2. Choose those 2 that that we are talking about, times 5 factorial, so mess up the other ones, times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial minus 1 over 5 factorial divided by 7 factorial. This ends up being the same as 1/2 times 3 times 4 times 5 minus 4 times 5 plus 5 minus 1 over 5 factorial. And after we do the calculations, that's 11 over 60. And we just continue with the same thing. Probability that x is 3 is 7 choose 3 times 4 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial plus 1 over 4 factorial over 7 factorial. This ends up being 1/16. Probability that x is 4 is 7 choose 4 times 3 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial, and the whole thing divides by 7 factorial. That ends up being 1 over 72. Probability that x is 5 is 7 choose 5 times 2 factorial times 1 minus 1 over 1 factorial plus 1 over 2 factorial divided by 7 factorial. And that's 1 over 4 factorial times 1/2 minus 1/6, so it's 1 over 240. The probability of x equal to 6, we can actually guess it to be 0, but you can just write it out as 7 choose 6 times 1 factorial times 1 minus 1 over 1 factorial over 7 factorial. It's 0 because when x equals 6, then that forces x equal to be 7. If 6 codes are matched, then the 7th one is matched too. And finally, probability that x is 7 is 7 choose 7 times 0 factorial times 1 over 7 factorial, so it's 1 over 7 factorial, which is 1 over 5040. And therefore, the expected value of x is 0 times 103 over 280 plus 1 times 53 over 144 plus 2 times 11 over 60 plus 3 times 1 over 16 plus 4 times 1 over 72 plus 5 times 1 over 240 plus 6 times 0 plus 7 times 1 over 5040. We actually don't really have to calculate the probability that x is 0 for this calculation, but we did. And then we calculate this, and all this adds up to 1. And that's a very important observation. The expected number of codes that will go to the right person is 1. Answer D. By the way, if you study this question in my exam piece manual, BTDT manual, then I have the complete general formula. No matter how many codes you have, it's always 1. Always 1. And I show that general formula in the book. So you should get the book. Please remember this is copyrighted material. The problem came from me. The solution is mine. Good luck with your studies. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.